Hi and welcome to the Naval TIG Tinkerer. My name is Mikael Sjöman and I just wanted to give a small update of the outboard 3D printed 20 kilowatt or 26 horsepower electric outboard that I'm building. This is my second project and we're kind of mid through, maybe a bit further ahead than I might think right now. But I just wanted to show where this motor is right now. So this is how it looks right. I'm sorry if I have the 3D printer running in the background, but I wanted to give kind of how it looks right now and what I have and kind of my next steps, what they are. So if we start from the bottom, I have kind of a keel of some sort, and the idea is that this kind of carbon tube that I have here, it's actually steel inside of it, but yeah, it's just a tryout. Maybe I'll make it in pure carbon. That should actually run from here, back here, and then I'll create some support in between here. So this one is not just connected through force. Let's see if I can get this off. There we go. So you can kind of see that I put two through right now. I have to sand this a little bit because, yeah, maybe I'll optimize this before I release the design so that the angle of printing won't be that hard, or yeah, it won't have a good big overhang. But yeah, so we have a pipe down here and a support, and I had to throw away the one I made. I had friends over last night who helped me out kind of putting this together, because you almost have to be two right now, it feels like. And then I have the carbon mast, or whatever you want to call it. It's actually PETG with two layers of carbon fiber to create some strength. And then the idea is to connect this to the boat. I will have to be able to move the the motor in this direction, so I have a hinge here, and yeah, I'm actually printing the hinge to the motor or the boat mount here right now. You can hear it in the background. This is printed in ABS. I think ABS is wonderful. I didn't think I could print it well, but apparently my machine works really well with it, and it's sandable, so I can sand this really nice later. I just put these here so look. It's not that they're tightened or anything. I won't use these. I will use stainless ones. I just want to see how it kind of looked. And then we have what we call in Swedish peke, which is to kind of move this motor around. So I redesigned those from the original that looks like this to something a bit more stealthy looking. I think that's pretty neat. I like the design of that. So my next steps right now is to build a hinge to the boat mount so you can tilt it upwards, and that you can also, well, connect it to the boat. So you want to be able to move it like this, and you want to be able to tilt the motor up and down. And then I have this one, of course. This is in PETG right now. I won't have two different ones. I'll reprint this one in ABS. Looks way nicer. This kind of matte white color. And I have pulled the lines from the motor through here. So basically what happens is that 3 or 4 cables actually go from here, and then I built inside here kind of the hole which should run through all the way up. And I also have a water intake hole, so I haven't drilled that yet, but there is actually in the 3D printer part inside here going kind of a line of air that you can just pull water in from here, and then by force it will just put pressure, and the water will rise upwards, I think. If it doesn't work, I have this one, 12 volt pump to pull water if necessary. So I have some attachment here I'll put on, probably with heat, and then I can pull water into this one, then to the motor controller, and these cables will connect to the motor controller in the house up here. So I don't want to make a long video of this. I'm kind of happy with how it looks. I think it looks neat. Black carbon against white. The reason I'm trying to use a lot of white here is that I'm a bit worried about the PETG right now, and I would love this to at least last the first summer. I'll probably remake this without the PETG or put ABS instead and just do the same thing. It's also a lot of, not a lot of resistance, but this could be made way thinner. So yeah, I mean, it only goes down here, and then I have this carbon wood mast running all the way through here. You can kind of see it here. And this is I need, like, I'm bolting 3 screws from under here to the wood to kind of push this up here. And then the idea is that the housing will push downwards, which will put pressure on everything to kind of stay together. So that's the idea I have right now. I'm kind of building a diamond shaped thingy up here, pretty small, because as the first stage, I don't want to put my 300 amp controller. I want to put a 100 amp controller with a max at 120 for a few seconds, I think 10 seconds. So yeah, I think it's gonna look real cool when it's done. I already like the design of it. So yeah, this was an update for this time. I hope you like what you see, and if you don't, let me know. I should probably have ball bearings. So actually I will have ball bearings not on these, but on the thing connecting here. I want to distribute the loads a bit better, so one down here, one down here. Maybe I'll reprint and put out here, but you can kind of see that there's not too much plastic, so I would have to redesign that to make it stick well. So the forces of this is kind of a critical point. All the force of that motor will kind of push like this. So this part will be under compression, so this is pushing in, and that one will be under tension, I guess it's called in English. So compression and tension, because the motor is trying to push that like that. So there's going to be a lot of power here, but ABS is strong. It's also a bit ductile, so it doesn't break immediately. I don't know about that. That's not what my test has been saying until now. But yeah, I think it looks nice. Let's see if it just immediately breaks. But at least I'm aiming right now to not have it at 20 kilowatts power. So I'm gonna take this battery that I built with waterproof connectors, and I'm gonna split this in two, like I said in the previous battery build video. I built this the wrong way. I built this 72 volts. That's not okay for marine environment. So I'm just gonna parallel connect. I have like kind of one layer down here with batteries, and then second layer with batteries down here, up here. So they're 10S times 2, so 10 in series, 10 in series, and then 21 or 22 in parallel. I actually don't remember. I have to look inside. So yeah, hope you like what you see. Let me know. Cheers.